Hey guys, so for this video what we're going to be doing is we're going to be working on part 1 of 5.3, practice with solving all types of trig equations. So what we're going to do is we're just going to work on the rest of the questions that we didn't get to in class today. So we're going to go and start with tangent of 3x is equal to 1. So what this equation right here is called, it's called a multiple angles equation. And we're going to solve it just like normal. We just are going to use a little bit of substitution. All right, so the first thing we're going to do, tangent of 3x is equal to 1. I'm going to go ahead and kind of just think out loud for a minute. Tangent of 3x equals 1. I don't know very much about tangent of 3x, but I know a lot about tangent of just regular x. So what I'm going to do is I'm going to replace 3x with a variable. I'm going to replace it with j for Johnson. So we'll say tangent of j, is equal to 1. Okay, so I just want to know where in my unit circle, and remember that you can keep your unit circle next to you the whole time, where is tangent equal to 1? Well, if you remember that cute little trick that we learned, anytime tangent or cotangent equals -1 or +1, your value is always going to be pi over 4. So it's always going to be over 4. So let's take a look at all of the pi values that are over 4. So there's pi over 4, there's 3 pi over 4, there's 5 pi over 4, and there's 7 pi over 4. So I just want to know which one of these are going to give me +1. Well, pi over 4 is radical 2 over 2, comma radical 2 over 2. If I divide both of those by each other, if I say tangent is y over x. If I say y divided by x, that equals 1. So the first one I'm going to say is that j is equal to j is going to equal pi over 4, and we want to write this generically because none of these have any restrictions. So I'll say pi over 4 plus the period of tangent. Well, the period of tangent is pi times n. N is just an integer. Next one, 3 pi over 4. Let's see if that one works. Its ordered pair is negative radical 2 over 2, comma radical 2 over 2. If I divide these, I get -1, so that one doesn't work. Let's check 3 pi over 4. If I check 3 pi over 4, that's negative radical 2 over 2, comma negative radical 2 over 2. If I divide both of those, a negative divided by a negative is a positive. And so 5 pi over 4 works. So we're going to say, comma, 5 pi over 4 plus the period, which is tangent. The period of tangent is pi times n. All right, so you might think that this is the answer here, but remember that we're solving for x, we're not solving for j. And so the very last step that I want to take is I want to replace j with what it is. J is 3x, and so we're going to say 3x is equal to this whole thing, is equal to pi over 4, pi over 4 plus pi n, plus 5 pi over 4 plus pi n, comma. All right, so what I want to do in order to solve this completely, I'm just going to divide everything by 3. Another way of saying that is I could multiply everything by a third. So if I multiply everything by a third, that is going to cancel out the 3 here. And what we're going to get is that x is equal to pi over 4 times a third is pi over 4 times 12, which is 4 times 3, which is 12, plus pi over n divided by 3. Next, I'm going to get 5 pi over 4 times a third, which is 5 pi over 12, plus pi n over 3. And so that right there is the solution to the only multiple angles question on the review today. All right, so we're going to go ahead and move on to the next question. So the next question, and if I'm remembering right, I don't think we did number 2. Nope. We're going to do number 2. So this one looks like this. 3 secant squared x minus tangent squared x minus 4 is equal to 0. So I want to go ahead and solve this. So 3 secant squared x minus tangent squared x, that's times 2, minus 4 is equal to 0. So what we really need to focus on here is, let's just talk about things that I can do. We'll just talk about things that I know that I can do. So one thing that I can do, things that I can do. All right, one thing I could do is I could combine like terms. Except if I'm looking at this equation right now, I don't have any like terms. I have secant squared, I have tangent squared, and I have a number. So I can't do that. I could look to factor, except if I'm going to factor, I need to have all the same trig values. And right now I don't. Okay, so it's looking like a pattern here. Everything kind of depends on me having the same trig value. Other things I could do is I could look for a common factor. I don't see one of those. And other things that I could do, I'm trying to think of anything else I could do. That's probably all the things that I can think to do right now. All right, so all of them kind of hang on this. I need to get everything in terms of one trig function. So whenever I think about that, if I need to get everything in terms of one trig function, what I really need to do is I need to use an identity. So I know we just got off the chapter that has to do with verifying trig identities. I need to use an identity here. So what I'm going to do, I'm going to go up and I'm going to look up some identities. So we're going to look up reciprocal identities and all of its relatives. Here we go. So let's go ahead. We'll put this on our screen here. So we have all of these identities. I want to know a couple of them. Let's see if any of them are going to be helpful. All right, let's go back. Where am I at? Here we go. Sorry, I'm just copy and pasting right now. All right, so here are some identities that may or may not be helpful, and I'm going to go ahead and move my head too. Okay. All right, so if I want to get everything in terms of one variable, let's take a look and see if any of the identities help us with that. So let's highlight, I think Pythagorean identities, those are going to be the most helpful. Okay, well, taking a look at that, I know that secant squared is equal to 1 plus tangent squared. In fact, it's already solved for us. So I'm going to just pick the easiest path. I'm going to replace secant squared with 1 plus tangent squared. So I'm going to go ahead and replace that. So we'll say 3 times 1 plus tangent squared, and that's just a Pythagorean identity, x, minus 2 tangent squared x, minus 4 is equal to 0. If I distribute the 3 in, I'm going to get 3 plus 3 tangent squared x minus 2 tangent squared x minus 4 is equal to 0. 3 tangent squared x minus 2 tangent squared x is 1 tangent squared x. 3 minus 4 is minus 1 is equal to 0. So we're getting really close to solving this. We're going to add 1 to both sides. And so what I'm going to get is tangent squared x is equal to 1. If I think about what we did a couple of chapters ago, we talked about inverses, and we thought about what undoes things. So if I think about, hey, what undoes a square function? Well, what undoes a square function is the plus or minus square root function. So I'm going to take, and be careful here, I'm going to take the plus or minus square root on both sides. So that's going to cancel out the squared, so then I get tangent of x is equal to, well, the square root of 1 is 1, so this is going to be plus or minus 1. That is equal to the same thing as me saying 1 and negative 1. All right, so let's think about, when does tangent of x equal 1 and negative 1? Well, thankfully for us, the last question kind of gave us the answer to one of those. Tangent is equal to 1. Tangent is equal to 1 at pi over 4 and 5 pi over 4, so we kind of already have half the answer. So we could say x is equal to pi over 4 plus the period of tangent, which is pi n, and 5 pi over 4 plus the period of tangent, which is pi times n. The next question is, when do I get negative 1? Well, I get negative 1 at all of the other pi over 4 values. So at 7 pi over 4 and at 3 pi over 4. So really all of the pi over 4 values are going to be represented here. So my answer is also going to be 3 pi over 4 plus pi n and, sorry, not 3 pi. Oh yeah, and 7 pi over 4 plus pi n. All right, so I think we have time to do about one more question here. So the last question that I want to work on, if I'm remembering right, I think I want to do, we're going to do a factoring question. So the last question that we're going to do, we're going to work on this one here. 2 sine theta cosine theta plus cosine theta minus is equal to 0. All right, so the first thing that I want you guys to do here is take a look and think about the things that you know to do. So what are some things that you can do? All right, so some things that we can do here. Let's go ahead and just write a list, just like we did last time. So some things that I know how to do. So some things that I know. All right, so some things that I know how to do. Well, I could combine like terms. Well, I can't really combine like terms here because cosine theta times sine theta and cosine theta aren't like terms. So in this case, we have no like terms. Next thing I can look to do is I could factor. And that could mean factoring like a trinomial. It could be factoring a common factor. In this case, I see a common factor. The common factor is kind of easy to spot. In fact, you could probably spot it even if you didn't really know what factoring was. You could see that both terms have cosine theta in them. So the common factor is cosine. So what I'm going to do is I'm going to factor out cosine theta. I'm going to factor out cosine theta. So we're going to take a cosine theta out. And what is left in the inside? So here's a little trick I use. Just be careful with the trick, obviously. Don't actually go dividing. A little trick I like to use to know what's in the inside is if I'm taking cosine out, that's the equivalent of me dividing by cosine. And so what's left on the inside is going to be 2 sine of theta. And then what's left on the inside here, if I divide by cosine, is going to be 1. So I'm going to say plus 1. All right, so all I need to do now is use the zero product property. I have two things multiplied together and they equal 0. So be careful. The zero product property only works when I'm setting something equal to 0. It doesn't work if I set it equal to any other number. And so let's go ahead and see. Cosine of theta is equal to 0, and we'll have 2 sine of theta plus 1 is equal to 0. So where does cosine of theta equal 0? So basically, where does cosine equal 0? Well, cosine is equal to 0 here at pi over 2, and it's equal to 0 here at 3 pi over 2. So we're going to say pi over 2 plus the period of cosine, which is 2 pi n, and 3 pi over 2 plus the period of cosine, which is 2 pi n. All right, let's go ahead and solve the other part. So we know half the answer. All right, so 2 sine of theta is equal to -1. Divide by 2 on both sides. I want to know, when does sine of theta equal -1/2? All right, well, that's really asking, hey, where do I have a y value on the unit circle of 1/2? All right, so let's go ahead and check the unit circle and see, where does the y value equal -1/2? Well, if I'm thinking about y values are always going to be something that goes up or something that goes down. If it's negative, that means I'm looking for things that are going to be in the 4th quadrant here and in the 3rd quadrant. In fact, sine is going to equal -1/2 right here at this angle and right here at this angle. This is going to be 7 pi over 6, and it's also going to be 11 pi over 6. And those two right here are going to be my final solutions, and I'm going to write them generically. So theta is going to equal 7 pi over 6 plus pi n, and it will equal 11 pi over 6 plus pi n. All right, so that's really all we have time to get done today. So be studying today for that 5-3 quiz, which is going to be next week. If you have any questions, feel free to message me, and I will get back to you.